In this video, you'll be learning how to make a spreadsheet. Your spreadsheet here is going to be for the Elastic Energy Lab. In this Elastic Energy Lab, our purpose is to be able to find a little bit more about springs so that we can apply it to a bungee jump. In this lab, our setup is over here, and just after a quick explanation, we will get started with actually programming the video. So if you look at the spring here, the starting height is at the top, and that will always be the same. And you're going to release a mass, and so that will start stretching the spring. You can figure out the starting height and the ending height both from the video. And by doing that, you should be able to find the distance stretched by doing a simple algebraic calculation. And that is found over here on the side. Distance stretched equals the starting height minus the ending height, which leaves you what's left over here in blue. Now, we are looking at trying to find the relationship between the distance stretched and how much elastic energy got stored in the spring. And you can see from our energy bar chart on the side here that we start at the top with gravitational energy in red. And all of our energy is as gravitational potential energy. Then the spring stretches out as the mass falls, and we lose gravitational energy, and that energy gets transferred into the spring as elastic energy. And in order to calculate what the elastic energy is there, then we can take the starting gravitational energy minus the ending gravitational energy, and that will give us what elastic energy is left over. Now we can start doing our calculations here off to the side. We're going to be using spreadsheets because if we make these calculations once in our spreadsheet, it will automatically calculate for us for the rest of the time. So once we set it up once, it will be in a great shape for later. We will also be using a different lab as our template for this. This was a lab that you might have done, you might not. It's kinetic energy lab, and we'll be modeling our spreadsheet after this one. All right, now the first thing that we want to do here is we're going to be changing the font size for all of our font. And to do that, you go up to the top left corner, and we think that 10-point font's a little bit small, so we're going to go ahead and start it with 12-point. So we select everything, and let's make it 12-point. Another thing that we're going to do is we're going to text wrap. If a cell is not text wrapped, what it does is when you start writing here, it will jump into the next column to it. So when you text wrap something, what it does is it will wrap it around in that column and automatically fit it. So to do that, again, you're going to select everything, go up to text wrapping, and click in the middle there. Right. The last thing that we're going to do with all of our cells is we are going to align them to the middle. So you're going to go up to these horizontal lines and click on the middle one. All right, great. So now let's go ahead and start modeling it after this. We're going to make our controls, we're going to make our data table, and go from there. So let's start here. I'm going to do this bold, so I often will press Command or Control B. That'll make it bold, or you can click up there. So we controls. And really, we only have one control here. It is gravity. That is the control that's staying. Our starting height's going to end up in our thing, and our spring is our control. We can put that in later. So gravity is a control, and on Earth the gravitational strength is 10, and we're going to leave that 10 there, and this is where we're going to put our units. Be intentional about not putting the 10 meters per second in there. Again, this is the strength of gravity. All right, then going down, you can see how we did this here. Mass is not going to be a control in our lab. We're going to be changing the mass. So we can go down to our data table, and again, we're going to bold it. Go to data table. And we want this to be graphed on the x-axis. I'm going to just grab this, copy it over, and this side's going to be graphed on the y-axis. Again, I just went Control C or Command C, and or you can copy and then paste. All right, so the two variables that need to be graphed are distance stretched and elastic energy. Now, I forgot to put units in here, so our distance stretch is going to be measured in meters. And that's going to be plus or minus 0.05. And for our elastic energy, that's going to be in joules. That's going to be plus or minus 0.4. Those are really important columns, so I'm going to bold that. All right, we're going to take 5 data points, so let's go ahead and set up this data table as we would. So I'm going to click up here and then hold it down and select all of these cells. And I want to do a few things. I'm going to put borders on, and so to put borders, you go to this button up here, borders, and I'm going to put a black border on, and so I'm going to hit all borders. I also want to color this to be graphed on x-axis. I'm going to fill and color as light yellow, and the y-axis I'm going to fill and color to be light green. So you have to go to the bucket here and hit light green. Great. All right, next thing I'm going to do, I'm going to do this pretty quickly, and you can pause after this if you need to. We're going to do mass. So these are the other variables, the variables that need to be taken from the situation, the lab, and then also calculated. So that mass is going to be in kilograms. Starting height in meters. I'm going to copy that over and use some of my own writing. Ending height. This is going to be starting gravitational. Some joules. And yours might not fit here, so what you might want to do is pull this over and move this so that it fits, and in gravitational energy. Again, it might not fit. Go in between the I and the J, and then it might. All right. Other things I want to do here is I'm going to just kind of make it look nice. I'm going to bold that. I want to highlight, and I'm going to do all borders. And I was actually off by a column here, so I made a mistake. I was off. I want to be in row 8, not row 7. So I'm just going to select. I'm going to go Control X or cut, and I want to paste it one row down. That will fix my error. All right. Next thing we're going to do, we're going to start doing a calculated column. So I want to show you how to merge and show that this is calculated. So if you highlight these two, you can go to this button here that says merge cells. You can also two-finger click and scroll down to where it says merge. The easiest is up here. So I'm going to merge cells. These are calculated. And I'm going to center this. And these cells here are from the experiment. And I'm going to center those. All right, so we're close, we're almost there. In my setup, my starting height is 1, and our mass changes. You can change the variables that are there, or how many decimal places that are there, by increasing or decreasing the decimals. I like to leave it like this. Our mass changes, but just to give a test mass, I'm going to say 5 for now, and just to see if our calculations are working. And I'm going to turn this red so I know to delete that. And ending height, I'm going to put in 0.2, and again, I'm going to turn this red. You should too, so that you know that that's actually not a point that we got. Going to delete it. All right, we want to do a couple calculations here. Starting gravitational energy, we know gravitational energy to be mgh, and we know that it's multiplying there. So in Google Sheets, to make it a calculation, you're going to say equals sign. I'm going to, instead of writing in m, I want to click on the cell that means mass, because m is for mass. I will click on E9, and you can see it's 5. That's working right. You have to tell it to multiply, so you hit Shift 8, it starts multiplying, and G is the strength of gravity. That's what we want to multiply by, which in our cell is 10. So I'm going to click up here to the 10, and I'm going to do something important. I'm going to put a $sign before the C and a $sign after the C. What that does is that locks in that cell so it doesn't change. All right. Then I'm going to multiply by, this is starting gravitational energy. I'm going to look at starting gravitational energy, which would be here, and that must have to do with that starting height. So I will multiply by my starting height, which is F9. Great, and hit enter, and that should be calculated. All right, now we want to repeat this calculation. So in the bottom left-hand corner, when you have H9 clicked on, you can click and drag down, and that will repeat the calculation. You can look up here, and that calculation is repeating. The E column and the F column should move on, while the C3 should be locked in place. And as we see here, that's true. Mass times gravity times height. I'll go down to my next cell. Mass times gravity times height. Great. Okay, the next thing you're going to do is the ending gravitational energy. It should be quick. Since we just did starting with mgh, it's the same, but instead we're going to use the ending height. So I'm going to do this. I'll say m times g don't forget your $signs times the ending height. Calculate it out, click, and drag down. Okay. Just for the sake of coloring, I'm going to change the color of these to blue, and we'll go light blue for my experiment, and a little bit darker blue, again going up here, for my calculated. All right. The last ones that we need to do are here. distance stretched, and elastic energy. Now you have the equations here, and I want you to go ahead and make those calculations. So remember, to start an equation, you hit equals. To repeat the calculation, remember going back here, we clicked and dragged down, and we already have the equations here for you. Distance stretched is here, we talked about that, and elastic energy is here. Go ahead and program in these cells now. And then when you're done, make sure that you go back and delete the red ones that we made, because the red columns there, or red data points, are actually not data points, and I'm even going to turn them back black so that we know that we did not mess that up.